Hello and welcome back to IXL tutorials. This is Mr. Duffick and we are continuing on with symmetry today, specifically with IXL 04, which is counting the lines of symmetry on certain shapes and objects. So here we have a cue, and instead of actually drawing the lines of symmetry like the last IXL 03, we just have to state how many we think there are. So if we look here, no matter where we draw a line, it's not going to overlap on itself perfectly. Some of you might be confused and try to draw a line through that thing and up and say that overlaps perfectly, but remember, this thing looks kind of like a parallelogram. So if you were to fold this in half, put a line there and fold it in half, that corner is going to end up slightly above that one, and that one's going to end up slightly below, so that is not going to overlap. So there are no lines of symmetry here. Okay, how many lines of symmetry does the shape have? Just the one right here, because you can try to put a horizontal one anywhere else and you're not going to find it. You can try to put a vertical one anywhere and it's not going to do it as well, so we just have the one. Okay, same deal here, we just have the one in the middle. Okay, here we have the one in the middle for sure, and then we have no other vertical ones, we have no other horizontal ones. Okay, so I'm going to start skipping the level. These are all 1. It kind of looks like you start at simple shapes with 0 or 1, and then you go up to multiple. So how many lines of symmetry does this polygon have? Well, we have 1 here and 2 here, and then 3 here, and then 4 here. So I would put 4 for that. Okay. How many lines of symmetry does this square have? Several. You have 1 and 2 for the corners, and then 3, and then 4. Okay, kind of a general rule of thumb. Count how many sides or corners something like this has if it's symmetrical, and that's going to be how many lines of symmetry it has. So like the last one had, now I'm forgetting what it was, but it had 2 or something, 2 sides. So this one's just going to be 4. Submit. Okay. And I just said count how many sides or corners of symmetrical shapes, or perfectly symmetrical shapes. This rectangle is not. So again, students try to put a horizontal line or a diagonal line from corner to corner there. It does not work. For rectangles, you only have the bases and then the sides here. So it's just 1 and 2. Okay, rhombus. So for a rhombus, you can say that it might have 1 specifically. That would be right here. You might also say it has a second one right here for a rhombus specifically. Okay, if you were to try that, well, let's see what happens. That is correct. Good. Now that's not going to be the case for all parallelograms. Remember, a rhombus has equal sides for all 4, so it's like a diamond, so it would work that way. For a parallelogram, that's not a rhombus. It's not going to have any. How many lines of symmetry does this regular polygon have? Okay, well, it is a regular polygon, so we'll just count the sides. 1, 2, 3, 4, 5, 6, 6. So I'm going to write 6 here, and that's going to be 3 through the sides and 3 through the corners. Good. This one has 1, 2, 3, 4, 5, 6, 7, 8. 8. Again, 4 through the sides and 4 through the corners. So it's going to be 8. Okay, we have 1, 2, 3, 4, 5, 6, 7. So that is going to be 7. We have 5. It's a regular polygon, so a pentagon. It's going to be 5. 1 through each of the corners. Okay, this is a standard parallelogram. This is what I was warning you about earlier. Students will try to put it kind of like diagonally like this, but if you do that, this corner is going to end up like over here, and this one like over here. They're not going to overlap. If you try to put it down the middle, this one is going to end up here. This corner is going to end up here. It doesn't work. So this parallelogram, it's not a rhombus because all 4 sides are not equal length, right? It's not going to have any. So remember that, and you should